Combined sections 8 and 9, we're going to be talking about the differences of squares as well as perfect squares. And most of the stuff we cover in this lesson will be similar to what we did in one of our earlier lessons in this chapter, where it's just kind of a shortcut on how to do something, and it's not so much actually doing anything different, it's just a faster way to do things. So the first thing we're going to do is to factor the differences of squares. So we've talked before about the product of a sum and difference of two qualities, okay? This resulting product is the difference of two squares. So what we did before, we had this a plus b times a minus b. You guys remember that? And then if we would FOIL that out, we would just end up with a squared minus b squared. Okay, so for example, when we had x plus 5 times x minus 5, we just got x squared minus 25. Now we're just going to be going the other way. We're going to go from something that is x squared minus 25, and we're going to factor that into the two binomials. Just like in the previous lessons, we've been working on factoring trinomials. Now we're just going to factor these special situations. So if you ever see something squared minus something else squared, the way to factor that would be a plus b times a minus b, or obviously you could write it as a minus b times a plus b. The order of these two does not matter, as we've discussed before. So for example, if we look at the second one, t squared minus 64, well, t squared is obviously something squared minus 64, and if you don't know what 64 is squared, 64 is 8 squared. So then I've got something squared minus something else squared, like a squared minus b squared, which means I would have a plus b times the quantity of a minus b. Just using this simple formula to help us work through these. So if we look at our first example, we want to factor each polynomial, and it's only going to work if we have two squares. Now, looking at this first part, I've got 16h squared, which I really know is 4h all raised to the second power minus 9a squared, which I know is 3a all raised to the second power. Since I know it is something squared minus something else squared, I can use that formula. So I do 4h plus 3a times the quantity of 4h minus 3a. The only tricky part here is being able to see what's squared, but hopefully you can see that 16h squared, the only way that would work is if it was 4h all raised to the second power. Remember, when you put them in parentheses, you would end up squaring the 4 and the h to get the 16h squared. Looking at the second one, we've got 121 minus 4b squared. 121 is just 11 squared, minus 4b squared would be the same thing as 2b all raised to the second power. So I have 11 squared minus 2b squared, which means when I would factor this, I would get 11 plus 2b times the quantity of 11 minus 2b. Now this third one is a little trickier, but what we can actually end up doing is factoring out a g. Okay, see how we have a common factor of g? So I could get g times the quantity of 27g squared minus 3g. And then if you notice, and I should have seen right away, I also have a common factor of my numbers of 3. So I could actually factor out 3g, not just g, and I would get 9g squared minus 1. Okay? So I'd have 3g times the quantity of 9g squared minus 1. Then if you look inside these parentheses, okay, and I'm just going to bring my work up over here, I'd have 3g times 9g squared could be rewritten as 3g all raised to the second power, minus 1 could obviously be rewritten as 1 raised to the second power. And now notice, just like in these first two examples, I have something squared minus something else squared. So I get 3g times the quantity of 3g plus 1 times 3g minus 1. Okay, hopefully not too confusing. Just remember the main idea here is that we have that a squared minus b squared, and if you ever have something written as something squared minus something else squared, you can write it, factor it out to be a plus b times the quantity of a minus b.